Now, undoubtedly, among all of our cognitive abilities, language clearly stands out as central to the human experience. The ability to communicate, more or less complex ideas, to transfer from in here to in there, internal, our own thoughts and our emotions and our plans for the future, undoubtedly a central aspect of who we are. Certainly, it also is a topic that comes with a lot of controversies. For example, one very difficult question is what is the origin of language? If you think of it, we share most of our DNA with our closest primate cousins, which does mean that we must have much of our cognitive system in common with them. And yet, there must have been one or a handful of changes which allowed us from that cognitive backdrop to develop fully fledged language. What was that change, or what were those changes? And then another question is the debate between nature and nurture, meaning how much of language, how much of it is innate? How much do we just come pre-programmed for? And how much of it do we actually learn? And then finally, of course, a really interesting question is language unique to us? I mean, undoubtedly, other species also have some forms of communication. How different is it from ours? Is it just a quantitative difference? Ours is this much and animals just have this much or something of that sort? Or is it just a whole different game? And these, among others, are a lot of the really interesting questions in the topic of language. But let me start from the basics. What do we mean by language? Well, there are several definitions of what language is. One excellent definition is by Harley, who said that language is a system of symbols and rules that enable us to communicate. But the reason I like this definition, it's because it really highlights the way in which in cognitive psychology we approach language. So you can think of language, or rather language is often divided into two aspects. On the one hand, e-language or external language. And this refers to language as an output that is transmitted and that is shared within a community. So in this sense, an e-languages could be French, Italian, Spanish, Hindi, Hebrew, American Sign Language, etc. So the code that is shared within a community. So that's what we refer to as e-language, the external part of language. But what we care about in the context of the modern study of language as a mental phenomenon is the internal language, or I language. And see, this refers to the internalized set of constraints that allow you and me to learn, understand, and produce language. So this must be a set of internal guiding principles that allow us to acquire and use language. And that is what we will focus on in this class. But what do you know about language? So take this sentence: the pig is eager to eat. It takes but a second for you to realize that the situation that is being described is that there's an animal who would very much like to eat. And you accept this as a perfectly valid English sentence. Now, if I said the pig is eager to eating, you would immediately realize, although you might understand what I mean, that this sentence is grammatically incorrect. And you should know that typically when to mark a sentence as grammatically incorrect, we put little asterisks. So if you see an asterisk at the end of a sentence, it's because I'm marking it as grammatically non-correct. Again, you might understand what I mean, but obviously, if you're a native speaker of English, or if you know English well, this sentence should jump at you as grammatically incorrect. Now, if I were to ask you, how do you know that the sentence, which rule is being violated by the sentence to make it grammatically incorrect, it'd be pretty hard probably for you to tell me. On the other hand, if I said the pig is easy to eat, it'll take, again, just a moment for you to realize that the subject who's doing the eating in the first sentence and the third is very different. But why? What led you to interpret In this case, the pig as the subject of the verb, and in this case, the pig as the object of the verb. Take this sentence. The girl who kissed the boy closed the door. Now, it should be immediately clear, if you're a proficient speaker of English, that the state of affairs that is being described in this sentence is that there is a girl who's closing a door. Now, in fact, and this is so effortful and so automatic that if somebody told you any different, you'd think you don't understand English as a language. And nonetheless, you might wonder why, for example, we don't interpret the boy as being the person closing the door. After all, if you think of it, there actually is in this sentence the fragment, the boy closed the door. And yet that's not how we interpret it. Just the fact that the boy is so close to closing the door doesn't seem to be a principle by which we interpret sentences. The linear proximity of the boy to the verb doesn't seem to be a guide of how we interpret sentences. But so how is it that we so effortlessly and so automatically interpret the sentence as describing a state where there's a certain girl who just so happens to have given a kiss to a certain boy, and at the same time, the girl has closed a door? Now, one explanation, and I think this is the founding intuition of the modern study of language as a mental phenomenon, so as a cognitive phenomenon, is that despite the fact that language is typically manifested as a temporally linear sequence of utterances, meaning it's something that unfolds over time, you read a word at a time, in our mind, we spontaneously build a rich, abstract, hierarchical representation of how each discrete element within the sequence fits with each other element. And it's the building of these abstract relationships that allow us to understand what is being said. So in the sense, our mind has in it some set of rules that allow us to extract from a linear signal a set of hierarchical relationships of how each piece of the sentence fits within the sentence and connects to everything else. And that is what we mean by I language. What are these mental mechanisms that allow us to take this linearly unfolding signal and turn it into a set of hierarchical relationships of how each word fits and relates to each other word? Now, take this other example also. Jamal thought that Mark liked him versus Jamal thought that Mark liked himself. Very tiny change, but you immediately know the two sentences are completely, what is being expressed in the two sentences, completely different. And finally, yet another example. Take these sentences. Jazz gave a kiss to Lucia. It is Lucia that Jazz kissed. It is a kiss that Jazz gave to Lucia. It is Lucia that was kissed by Jazz. Completely different surface, sort of what is the actual signal that you're receiving in each of these sentences, completely different, but you know instantly that they all mean the same thing. And see, again, if I asked you, how'd you know? Right? You probably wouldn't be able to explain to me the rules. In the sense, your mind knows a lot about language. Your mind has a set of rules or has acquired a set of rules that allow you to interpret any well-formed, so any grammatical sentence. You, of course, don't necessarily know what are the rules, what these rules and what these mechanisms are in the declarative sense. It's probably difficult for you to declaratively tell me this is why the sentence is grammatical or this is why this sentence means what I think it means. So unless in our mind we have like a really long list of sentences that we've learned and stored in our brain, it must be that what we know about language is something similar to like a set of rules for understanding any sequence, well-formed sequence of sentence, and a set of rules for creating any possible well-formed sequence of words. And see, this would also explain why many of these sentences, you might have never heard them, and yet you had no difficulty understanding them. See, this is what we mean by I language. The fact that inside our mind, there has to be this set of rules or set of mechanisms that allow us to interpret novel sentences, and that allow us to forge and to speak novel sentences. Again, this is what we mean by I language. And again, as has been throughout this whole class, this also relates to computational complexity. Take this sentence: Mary can ride a bike. Now, it should be straightforward to you that this sentence can be interpreted in two ways. It could be that Mary is able to ride a bike, but it could also mean that she is allowed to ride a bike. And just from this sentence, it's hard to tell which of the two I mean. It could be either. Right? Now, if I were to so this sentence is two ways ambiguous. It could mean one of two things. It's ambiguous, and it could mean either of two things. So if I put two sentences like this side by side, Mary can ride a bike and Ayana can ride too, you'd imagine that this sentence should be four ways ambiguous. You'd imagine that the first one could mean Mary can ride a bike, meaning is allowed or is able to. And similarly, the second one, Ayana, also is either allowed or is able to. And yet, that's not what happened. See, I think you would accept it if I said that what this sentence means is that Mary is able to ride a bike, and so is Ayana. This sounds like a perfectly fine interpretation of the sentence. I'd imagine you'd also be ready to accept that the sentence means Mary is allowed to ride a bike, and so is Ayana. Perfectly fine interpretation. But I think it'd be hard for you to spontaneously interpret this as Mary is allowed to ride a bike and Ayana is capable of. That's just a weird interpretation. It's just not what comes to mind. Similarly, if I said, oh no, the sentence, what I meant with the sentence is that Mary is allowed to ride a bike and Ayana is capable of riding a bike. It's weird, right? This is not what comes to mind. And see, this is what we know as so-called constraint of parallel interpretation. When we have two ambiguous sentences, when we unite two ambiguous sentences, we tend to interpret them in the same way. What comes to mind when you read this sentence is that the first part and the second, you interpret that can in the same way. It just seems to be a constraint. That's what we spontaneously do. We interpret those two cans as meaning the same thing, either allowed in both cases or able in both cases. But we don't seem to interpret one way and one the other way. And see, and what I mean then is that there are some spontaneous constraints in our processing of language. Somehow our cognitive system seems to impose some constraints on the type of meanings that we can extract from sentences. And this is yet again an example of computational complexity. In fact, this strikes me to be exactly the same issue that we discussed in our first few lectures when we were talking about perception. You might remember this example when I told you, hey, if I had this and if I took off the white bar, what would you imagine would be here? You probably thought a continuous black bar, something like this. And yet nothing would prevent it from this being the case, right? Or this being the case, or an infinity of other things. But what comes to mind, your spontaneous interpretation of this is that it's two complete bars with the white occluding a piece of the black one. Now, these two are perfectly fine. It's just not what comes to mind. The same thing is true about this sentence. It could perfectly be that this means Mary is able to ride a bike and Ayana is allowed to. It could. It's just not what comes to mind. So again, it's the exact same idea, computational complexity. There are too many possibilities to be considered and no general purpose of resolving ambiguity. So our minds have a certain number of principles, of guiding principles, of biases that turn us towards one interpretation or another when there could be many more.